Mid-July, rural Lancaster County, Pennsylvania. A neighbor stands on her porch, surrounded by 8 spray bottles lined up along the railing like a small chemical arsenal. Her tomatoes are riddled with holes. Her cabbage leaves are lace. She has spent over $200 this season alone, cycling through products, reading labels, trying combinations that the internet promised would work and didn't. However, the garden next door, same heat, same air, same insects buzzing overhead, doesn't have a single chewed leaf. Not one. She walks over and asks what spray they use. The answer stops her cold. Nothing from a store. The family next door is Amish, and their secret costs less than a candy bar. 2 cardboard tubes, a handful of sticks, $2 total. But to understand how we got here, we need to go back to the beginning. Most gardeners start with the best intentions. Seeds in the ground, a little water, a lot of hope. Then the aphids arrive, then the caterpillars, then the spray bottles multiply on the porch like a small chemical arsenal. The garden that was supposed to feed the family starts to feel like a problem that needs managing every single week. The joy drains out of it. What was supposed to be simple becomes expensive, exhausting, and somehow still failing. The gardener stands in the middle of it all, bottle in hand, wondering what they are doing wrong. The answer is almost never what they expect. Here is the real problem. Modern gardens are practically designed to attract pests. Bare soil between plants acts as a pest highway. No confusion, no barriers, no predators hiding in the gaps. Insects travel freely from plant to plant, and nothing slows them down. The layout itself is an invitation. The spacing, the uniformity, the exposed ground, all of it signals to the pest world that this place is open for business. Walk down any conventional garden row in midsummer, and you can almost feel it. The openness, the predictability, the total absence of friction. Then comes the spray. Most gardeners reach for a bottle the moment they spot damage. But chemical pesticides don't discriminate. They wipe out ladybugs, lacewings, and parasitic wasps first. The beneficial insects that were already eating your pests for free. Once they're gone, pest populations explode with nothing to check them. You solve one problem and create 3 more. The spray that felt like a solution is actually accelerating the collapse. The bottle empties. You buy another. The cycle tightens. Weak plants make it worse. A nutrient-starved tomato or struggling cabbage actually broadcasts stress signals, chemical compounds released through the leaves that insects detect from yards away. Healthy plants suppress those signals. Struggling plants are essentially ringing a dinner bell. The pest doesn't even have to search. The plant does the advertising. It sends a signal into the air that says, "I am easy. I am soft. Come here." And they do. Every time. Monoculture rows seal the deal. Planting identical crops in long, unbroken lines makes it effortless for a single pest species to locate a host plant, feed, and spread to the next identical plant 6 inches away. 1 aphid colony becomes 10. 10 becomes 100. The row is a buffet with no end in sight. Every plant is the same. Every plant is vulnerable. There is no friction anywhere in the system. The pest does not even have to make a decision. It just keeps moving forward. And the pest control industry? It profits from every repeat visit. The system is not designed to solve your problem permanently. It is designed to keep you calling, keep you buying, keep you dependent on a solution that only works until it doesn't. The label changes, the price goes up, the pests come back. The neighbor with 8 spray bottles on her porch is not a failure. She is the intended customer. The Amish figured out a different system entirely, and it starts underground. How does someone go from a bug-ravaged backyard to a garden that stops neighbors in their tracks? The answer is buried 12 inches below the surface, and most gardeners never think to look there. Every fall, before the first frost locks the ground, Amish families in Lancaster County do something their neighbors rarely bother with. They dig aged manure and finished compost deep into their beds, not a thin layer scratched across the top. Deep, 12 to 18 inches down, the kind of digging that takes an afternoon and leaves your arms sore the next morning. The smell of the turned earth is rich and dark, almost sweet, like something alive waking up. They have done it this way for generations, and the results are not subtle. Healthy soil builds healthy plants. That sounds simple. It is not. When a plant draws nutrients from rich, biologically active soil, it builds thick cell walls, genuinely thick. An insect trying to pierce that tissue with its mouth parts is working against real resistance, like trying to bite through leather instead of paper. A plant grown in depleted, compacted dirt has thin, weak cell walls, soft tissue that aphids and caterpillars can breach with almost no effort. The difference is structural, it is physical, and it starts in the ground before a single seed goes in. That's not a typo, by the way. The pest resistance isn't sprayed on. It is grown in, from the roots up, through the quality of the soil itself. You cannot replicate it with a bottle. But soil nutrition is only part of the picture. Crop rotation is the other half. Amish growers never plant the same crop family in the same bed 2 years in a row. Tomatoes follow beans. Brassicas follow root vegetables. The rotation breaks pest cycles at the source. A cabbage moth lays eggs in a bed this season. Next season, that bed holds carrots. The larvae hatch, find no host plant, and die before they can do any damage at all. No spray required, no intervention at all. The pest's own biology works against it. The garden uses time as a weapon. There is a third element that most gardeners overlook entirely: living roots. Bare soil in winter is not neutral. It is an open invitation. Soil-dwelling pests overwinter in bare ground, protected from cold, ready to emerge in spring directly beneath your new transplants. Amish beds rarely go bare. Cover crops, winter rye, crimson clover, hairy vetch, are seeded in the fall and keep living roots in the ground through the cold months. Those roots feed soil microbes. The microbes build structure. The structure supports the next season's plants before a single vegetable seed is sown. The ground is never idle. It is always working. Even in January, under a layer of frost, something is happening down there. The cost of all of this is close to zero. Kitchen scraps composted through the year. Wood ash saved from the stove. Aged manure sourced from any farm willing to let you haul it away, which is most farms. The inputs are free or nearly free. The labor is real, but it is seasonal. One serious afternoon of digging in October pays dividends across the entire following growing season. That is the trade. One afternoon for an entire season of stronger plants. And that wasn't even the part that got people angry. Because when researchers at Penn State Extension began documenting traditional Amish growing practices in the early 2000s, what they found contradicted decades of conventional gardening advice. Pest pressure in these gardens was measurably lower, not because of any single intervention, but because the entire system was built to produce plants that insects simply did not prefer. Strong plants, dense tissue, roots in living soil. Pests exist in these gardens, but they move on. There is easier food elsewhere. Think about what that means. The pest control industry sells the idea that bugs are an external problem requiring an external solution. A spray, a trap, a chemical barrier. The Amish model inverts that entirely. The garden itself becomes inhospitable to pest damage, not because anything repels the insects, but because the plants are too strong to be worth attacking. The pest arrives, takes one pass, and leaves for a garden that offers less resistance. Everything was in place. The soil just didn't know what everything was building toward. For a while, things actually seemed fine. The beds were rich, the cover crops were green, the rotation was holding. That didn't last. It is early May. The seedlings are 2 inches tall. The cutworms are already in the soil, waiting for dark. This is the moment every gardener dreads, and almost nobody prepares for. You go out in the morning, and a tomato plant that was perfectly upright the night before is lying on the ground, stem severed clean at the soil line. No chewing marks on the leaves, no visible pest, just a dead plant and a mystery. The cutworm did its work in the dark, underground, and was gone before sunrise. It does not eat the whole plant. It does not need to. It cuts the stem like a wire through clay and moves on to the next one. One cutworm can take out 5 plants in a single night. 10 cutworms can devastate a row before you even know they are there. You replant. They cut again. The cycle repeats until you run out of seedlings or patience. Some gardeners replant 3 times in a single May and never understand why they keep losing. But here's the detail that everyone missed at the time. The cutworm is not looking for your plant specifically. It is not hunting by sight or even by smell in the conventional sense. It moves through the soil and encounters a stem and it chews. That is the entire behavior. It is mechanical, automatic. It encounters resistance and it chews until resistance stops, which means if you change what it encounters, you change what it chews. And that is where the cardboard collar enters the picture. The collar is not a new invention. Amish gardeners have been using some version of it for generations. But somewhere along the way, modern gardening culture decided that the answer to cutworms was a bottle of pesticide, and the collar got left behind. A $2 solution buried under $40 products that do not work half as well. The knowledge did not disappear. It just stopped being passed on. The collar is exactly what it sounds like. You take a toilet paper tube or a paper towel tube from the recycling bin. You cut it into rings, each one about 3 inches tall. You slip one ring around the base of each seedling at transplant time, pressing it roughly 1 inch down into the soil. That is the entire installation. The whole process for one plant takes about 15 seconds. You do not need tools. You do not need gloves. You need a tube and a pair of scissors. You can do an entire bed in the time it takes to drink a cup of coffee. What happens next is almost elegant in its simplicity. The cutworm moves through the soil in the dark, navigating by touch and vibration. It reaches the cardboard collar. It tries to chew through. Cardboard is not what it wants. Cardboard does not have the cellular structure, the moisture content, the softness of a plant stem. The cutworm circles the collar, pressing its body against the outside edge, probing for a gap. It tries again from a different angle. It presses harder. It circles once more, methodical and blind, and then it gives up and moves on. Not because it is confused in any sophisticated way, but because the path of least resistance has been blocked, and there is nothing here worth the effort. The plant inside the collar is completely untouched. The cutworm never reaches it. One paper towel roll yields roughly 8 to 10 3-inch rings. That is enough collars for a 20-plant row. The raw material cost is effectively zero. You were going to throw the tube away anyway. One roll of paper towels. 20 plants protected. The math is almost embarrassing. The stick method works on the same principle but goes even further. At transplant time, you press a small twig flush against the stem of the seedling, so the twig and the stem are touching side by side. The cutworm approaches in the dark. It finds the stem. It begins to chew. But the twig is in the way. The cutworm chews the twig. The twig does not die. The twig does not matter. The plant survives. It is a decoy, a piece of dead wood from the yard performing the same function as a product that a pest control company would charge you $100 to apply. You can pick up the twig from the ground under any tree. It costs nothing. It takes 5 seconds to push into the soil beside the stem. The twig sits there all season, silent, doing its job in complete darkness. You will forget it is there. The cutworm will not. The clock was already ticking. The cutworm just couldn't hear it yet. Together, the collar and the stick create what you might call a physical perimeter. Not a chemical one, not a biological one. A physical one. Something the pest has to encounter in the real world, with its actual body, and cannot get around. There are no residues. There is no timing window. There is no risk to pollinators or beneficial insects. You put the collar on at transplant, you press the stick in, and you walk away. The protection is passive. It works while you sleep. It works in the rain. It works whether you remember to reapply something or not. It requires nothing from you after the first 15 seconds. What changed in the gardens where this was adopted was not dramatic on day one. The seedlings just survived. That was it. No fanfare. No visible battle. The cutworms were in the soil, doing what they always did, and the plants were simply still standing in the morning. Over a season, that quiet survival compounds. A 20-plant row of tomatoes that would have lost 4 or 5 plants in the first week stays intact. The root systems establish. The plants get strong. And strong plants, as you already know, become the kind of plants that pests are less interested in attacking in the first place. The collar does not just protect the seedling. It buys time. Time for the roots to go deep. Time for the stem to thicken. Time for the plant to become something the garden can actually build on. That is what $2 and a recycling bin actually buy you. Not just survival, a foundation. The seedling that survives the first 2 weeks of May becomes the plant that feeds your family in August. The gardeners who understood this early never went back to pesticides for cutworms. They just kept their paper towel tubes. One gardener saw it coming. She told her neighbor the collars would outperform everything in the pesticide aisle. She showed him the tubes, the twig, the whole system. Nobody listened. The pest is airborne. It is scanning. It is following a scent trail so precise it can locate a single brassica plant in a garden bed from 30 feet away. This is how most gardens get found. The pest does not stumble onto your crops by accident. It navigates. It uses chemical signals, volatile organic compounds released by your plants, as a map. Cabbage moths find cabbage. Aphids find tomatoes. Thrips find peppers. The scent trail is the address. If you can read the address, you can find the house. But what happens when you flood the neighborhood with competing addresses? What happens when the signal becomes noise? Pay attention to this next detail because it explains everything. Pests locate host plants by scent. That is the mechanism. Not vision, not memory, scent. And the Amish gardening tradition figured out, long before modern entomology confirmed it, that if you pack a bed with enough competing aromas, the pest cannot zero in. It circles. It lands in the wrong place. It gives up and moves on to a garden that is easier to read. The bed becomes, in effect, invisible. Not because the plants are hidden, but because the signal is scrambled. The pest is standing in the middle of the answer and cannot find it. The tool for scrambling that signal is companion planting, and the specific combinations matter more than most people realize. Basil planted between tomatoes is the most documented example. The aromatic oils in basil, linalool, eugenol, estragol are overwhelming to thrips, aphids, and whitefly. These pests approach the bed, encounter the basil signal, and cannot isolate the tomato beneath it. Multiple studies from agricultural research stations in Europe have confirmed what Amish gardeners knew intuitively. Basil does not just repel, it masks. One basil plant between every 2 or 3 tomatoes is enough to meaningfully reduce pest pressure across the entire bed. And as a bonus, and this part still surprises people, basil planted close to tomatoes has been shown to improve tomato flavor. The same volatile compounds that confuse the pest appear to influence the tomato's own chemistry. The garden becomes more than the sum of its parts. You get better pest control and better tomatoes from the same plant. Most people never heard about this part. Dill and fennel serve a different function. Planted at the edges of a bed, they attract parasitic wasps. Not the wasps you are thinking of, not the yellow jackets at your picnic. These are tiny, non-stinging wasps, most of them smaller than a grain of rice, that you would never notice unless you were looking for them. They are drawn to the flat-topped flower clusters of dill and fennel. They feed on the nectar, and then they go to work. These wasps lay their eggs inside caterpillar eggs and aphid bodies. The larvae hatch and consume the pest from the inside. One small colony of parasitic wasps can clear a caterpillar infestation in days, not weeks, days, and dill costs less than $2 a seed packet. Fennel self-seeds and spreads on its own, once established. The investment is essentially one time. You plant it once, and it recruits its own workforce every season after that. I mean, think about that for a second. You are not buying a product. You are not spraying anything. You are planting a herb at the edge of your bed, and the wasps arrive on their own, do the work, and leave when the job is done. The garden is hiring its own security. It is building a workforce out of plants that cost less than a cup of coffee. The pest control budget drops to nearly zero. The garden handles it. French marigolds operate on a third mechanism entirely. The roots of French marigolds, not African marigolds, specifically French, release compounds called alpha-terthienol and other thiophenies that are toxic to nematodes in the soil. Nematodes are microscopic worms that attack plant roots and cause the kind of damage that looks like nutrient deficiency, but is actually structural destruction below ground. You never see the nematodes, you just see the plant failing, yellowing, stunting, refusing to thrive no matter how much you water or feed it. French marigolds planted densely in and around a vegetable bed suppress nematode populations over an entire season. The flowers also deter beetles. The combination of root chemistry and flower scent creates a 2-layer deterrent that works above and below the soil simultaneously, one small flower doing 2 jobs at once. The rule of thumb that ties all of this together is simple. One aromatic herb or flower for every 3 vegetable plants throughout the bed. Not a border, not a separate herb garden on the other side of the yard, woven through, interspersed. The vegetables hidden in a forest of competing signals. Basil between the tomatoes, dill at the edges, marigolds tucked in the gaps. The bed does not look like a monoculture. It does not smell like one either. And that is precisely the point. The pest arrives expecting a clear signal and finds a wall of noise instead. The key moment is this. The pest arrives at the bed. It reads the signal. It gets basil, marigold, dill, fennel, a wall of aromatic noise. It cannot find the address. It moves on. The tomatoes underneath are never discovered, not because they were protected by something applied to them, but because they were hidden in plain sight. The garden became a maze, and the pest never found the exit. What changed in gardens that adopted companion planting was the nature of the pest problem itself. It did not become a problem you managed. It became a problem that mostly did not arrive. The difference between firefighting and prevention, between reacting and designing. The garden stopped being a target and started being a maze. Pests that had devastated the same beds for years simply passed over them. The gardeners who made the shift stopped buying pesticides, not because they decided to, because they stopped needing them. And then something else began to happen in the beds, something that had nothing to do with scent or chemistry, something that moved on wings and legs and made the garden feel, for the first time, genuinely alive. The garden had weeks before the next wave of pressure hit, and the clock had already started. The garden is never just plants. That video is on screen now.